Hey guys, Mr. Foreman here. I'm just recording a quick video to talk about how to convert numbers between binary and decimal number systems. So we're going to start going from binary to decimal, and then we're going to practice going back from decimal to binary. So the big thing we got to understand is that every number in the binary system represents a place that is a power of 2. So we always will start furthest to the right and understand that that's our ones place, and the next power of 1 is 2, so the next one is our twos place, times 2 is 4, times 2 is 8. So those four numbers that I've underlined and written those places, 1, 2, 4, 8, it's a 4-digit number, so those are the four values it can have. Then what we do is we check and we kind of see, okay, is there a number there? So 8, 1 means yes, there is an 8. 4, 0, that means no, there is no 4. 2, 1, that's a yes, there is a 2. And 1, 0, there is no 1. So I would write that as I would say, well, this number is 8, because there is an 8, plus 0, there's not a 4, plus 2, there is a 2, plus 0, there's not a 1, and 8 plus 0 plus 2 plus 0 is 10. So the binary value 1010 is equal to the decimal value of 10. And we'll go over a couple more, and you'll start to see the pattern. So this is a 1, a 2, a 4, an 8. And so similarly, there is an 8, there is a 4, there is not a 2, there is a 1, 8 plus 4 plus 1 is 13. So 1101 represents 13. Similarly, we can have longer numbers than 4 digits, and we just have to carry out the places. So 1, 2, 4, 8, 16, 32. So again, there is a 32, not a 16, is an 8, no 4, yes 2, yes 1. 32 plus 8 plus 2 plus 1 is 43. I'm doing these in my head. I do have this calculator up on the side for more complicated ones, and you are always welcome to use a calculator to check yourself. 32 plus 8 plus 2 plus 1, it is 43. And for this next one, I might need a calculator because it's a little bit longer. So 1, 2, 4, 8, 16, 32, 64, 128, and we're out of room, 256. And to put those together, that's 256 plus 128 plus 64 plus 32. Skip the next couple, plus 4 plus 1. I'm skipping the zeros just for my own sanity here. And then I'll put that in my calculator because that's a little too big even for me. 256 plus 128 plus 64 plus 32 plus 4 plus 1. And that's 485. So we see binary numbers can get very, very long. And we're going to see that in these examples when we go the other way. Because going back from decimal to binary is the exact same process, but in reverse. So we got to start thinking about those places. So the first place, like we said, and we're going to go from right to the left, and I'm going to give myself plenty of room, is the ones place, then the twos place, then the fours place, and then we'll say the eights place. So just like identified, up here, those first 4 digits of a binary number are 1, 2, 4, and 8. I'm doing the same thing here, and it's just important that I go right to left to identify the smallest furthest on the right. And what I do here is I see this, and I see, okay, an 8. 8 is bigger than 6. Hopefully you see that. This 8 is bigger than 6. So my question when I ask myself, does 8 fit into 6? The answer is no. So I know there's not an 8. So I could even not write the 8. You don't have to write a leading 0. But I like to show that. Well, 8 is too big. What about 4? Well, 4 does fit into 6. So I'm going to say that's a 1 for yes, there is a 4. And then what you have to do, somewhere, off to the side, even in your head for these simpler ones, you have to ask yourself, well, what's left? 4 and what is still 6? So that is, really a subtraction question. So when I've put that 4 into the 6, I still need 2 more. So then I go on, and my next number there is a 2. So 2 does fit. And obviously, if I take what's left is 0, so I don't need a 1. In other words, I do need a 4, and I do need a 2, and look at that. Just like going forwards, 4 plus 2 is 6. So then the way I would write this is you can drop any leading zeros. This is 110. You do need that trailing 0, that last 0. That is important because that's the ones place. We'll do another one very similar. So we're going to go 1, 2, sorry, that's the doorbell. You can ignore that. 8, and I'll show you the 16. Now again, obviously 16 is too big. 16 doesn't go into 9. 8 does, that's a 1. But once I take that 8 out, I've got 1 left. So 4 is too big, 2 is too big. I do need a 1. And that 8 and that 1, 8 plus 1 is 9. That makes sense. So again, I can drop the leading 0, but I need the trailing 0. 1, 0, 0, 1. Well, actually, it's not trailing 0. It's an ending 1. All right, we'll do a couple more quickly. Hopefully the doorbell doesn't ring again. 1, 2, 4, 8, 16. And again, 16 is too big. 16 doesn't fit. That's a 0. 8 does fit. 14 minus 8 is, here, I'll do it in my calculator. I think it's 6, but I'll double check. 14 minus 8 is 6. Always use a calculator if you're not sure. 4 also fits into 6. 6 minus 4 is 2. 2 fits into 2. That's 0. So no 1 needed. So 1, 1, 1, 0. Again, you need that trailing 0 is 14. And finally, we've got 41. I picked a bigger number here just to show that we can go out as far as we need to. Just takes a little bit more numbers. Not even harder numbers, just more. So we go up to 64. That's too big. 32 fits. 41 minus 32, I believe it's 9. Let's check. Or 41 minus 32. Yep, that is 9. That's a 3. So I still need 9. So 16 is too big, but 8 sure fits. So there's an 8. Minus that is 1. 4 too big, 2 too big, 1 fits. So 1, 0, 1, 0, 0, 1 is the binary representation of 41. So in order to be able to understand how a computer thinks, we got to be able to go back and forth. And here you go. That's how you go from binary to decimal, and from decimal back to binary.